All right, robotics and engineering students, just another video. Go over how I've gotten to this point. Hopefully some of you have begun working on this, have some questions. I haven't heard any questions yet. Nobody's posted them to Discord, so I'm assuming this is really easy for you. I would like to see you post some images of your projects onto Discord in the Fusion 360 channel. I just wanted to show you though how I got to this point within my Fusion 360 model. So here we are. I'm going to roll back the timeline. Let's open up the first sketch I made. A couple of things that are important and that are good practice that you should do when creating your model. The first thing is how I've dimensioned this part. Notice that all my dimensions have common sides. So I'm always using this line as a baseline for dimensions in this direction. In the same way, I'm using this line as the baseline for dimensions in this direction. And that's good practice in modeling, to have everything come from a standard baseline. It looks nicer and it's a better way to do things. So the ones that are a little bit different happen to be this one and this one, but these are just the dimensions of the actual box that I created in the beginning. So how did I get these dimensions? Those dimensions came from this data sheet, which I sent to you. You can see 2.70, that is the entirety, including this little edge here, distance of the Arduino Uno. If we go back to the model, here you can see 2.7, right? I've added a little bit of buffer, and this will be the actual edge of the project. This is kind of just giving me a little buffer so that the Arduino can sit within this space. So you can see 2.7 here, 2.1 here. Go back. 2.1 is the total distance width here, and 2.7 is the total depth. And so this is how I began to set this thing up. For these holes, again, you can see some of these have to be added. So I've got 0.55 plus a little bit, 0.05, so 0.6 to get to the middle of this hole, and then 2 to get to this edge. So if we go back to the model, here you can see 0.6 to get to the middle here of that hole, and 2 to get to the center point from that edge. Notice too, if you wanted to work in millimeters, let's see, so this is 2.1 inches. If we go to the data sheet, that 2.1 is 53.3. Go back to our model, we could type in 53.3 millimeters, and well, it's pretty darn close. So you'd be very close, and you can type in millimeters and still have your inches here. You might want to just round that up to 2.1 anyway. So now I've moved up once to the extrusion. I've extruded it. We just click on this. Here you can see 1.2 inches from the bottom. We'll move up again. This is the shell. One interesting thing about the shell that I've done here is you notice from the sketch that I had sort of the outside, the outside boundary of the Arduino plus a little bit extra. Well, that little bit of extra space actually represents this face here, the interior face of this box. In order to make sure that my model reflects that, when I do this shell, I've told the shell to go outside. So instead of shelling from the inside, it's going to add everything to the outside of that. And so now I can basically ensure that this inside edge is the distance I need for space and the Arduino to fit in. So that's a nice handy thing to have, is clicking on the outside. I've done 1/8 of an inch here. And so I've actually made my part a little bit wider now so that it can accommodate the Arduino Uno. We'll move forward again. 1/8 of an inch fillet, that should be pretty familiar to everybody. Forward again, I've basically just extruded the holes. They've been extruded up 1/2 an inch. Create another sketch because I wanted to create these standoffs. Posts here are going to go through the holes, the mounting holes in the Arduino, but then we want them to sit on something, a standoff. So I actually drew those standoffs. I could have drawn them in the beginning. I chose to draw them now. So here they are. They're actually 4 millimeters. This is what 4 millimeters is. And so you can see I've actually just created a sketch and drawn them in there. Okay. And then I'll extrude them in the next step. So if we move forward, There we go. We've extruded them. You'd like to see the height for that, 1/4 inch extrusion. And these are my standoffs. So the next step here was to turn this this body. We go back. Let's just go back here real quick. So here you can see I have sketches and I have a body, and this body is this bottom enclosure part. So the next step was to turn this into its own component. We're doing that because components can be joined together. So when we bring in the Arduino component, then we can have this as a component, and then those two things can be joined using the assemble command here. Moving forward, I turn this into its own component. Okay, I'll just go backwards one more time here, just so you can see. The way to do that is just to right click on it, and it'll say create components from bodies. You'll do that, and basically it'll give you this. So now you can see it'll say components number something. You can double click on that and rename it to whatever you want. The next thing I did was ground it. So if I just right click on it, this will say ground if it's not grounded. Right now it's grounded, so it's giving me the option to unground it, which I don't want to do. Grounding just means that it's going to stay in place when we do the join, so it cannot move. The next thing was, as you can see here, I brought in that Arduino. We click on the data panel here. The way to do it, I don't know, usually I'm able to just drag these in. For some reason that wasn't working for me the other day. So another way to do that is to right click on the part you want and just say insert into current design. So the next thing is to join. I chose what's called a rigid joint. Let's see if I can get that to show up. This is the joint panel. Basically, you'll need to select your component that you want to use, and then you need to select where it's going to be joined. So I chose the top of the standoff, and then the bottom of the Arduino mounting hole, which is actually in here right now. So next, I actually wanted to create a plane. So next, I wanted to create a plane on this front face so I can cut the holes so that the USB and power ports of the Arduino can stick through the component. So I just all I did was construct an offset plane, choose that front face, and tell the offset to be 0. Sometimes we choose to create a plane and we just click on this face. Well, that brings in the geometry of that face, and I didn't want to do that for this. So I'll create a sketch and use the project tool to project the exterior of this face as well as the exterior of the power port, which is back here. One thing I did do was hide the enclosure while I did that, so I could actually select that front face a little easier. And then I simply drew lines directly up from that. So from the projected surfaces to get to the top of the enclosure, and then did an extrusion to go through the enclosure. So that is how I've gotten to this stage. Now you've seen the step-by-step. See if you can get there just the same. And please show us your work. Send us your work on Discord. Have a great day.